We're looking at triangles that are similar today. Oops. If something is similar, does that mean it's exactly the same? The exact same? No. So what do you think similar means? How do you know if two things are similar? Nathan said if they look alike but they're not the same size. Yes? Okay. If the angles are the same, the corresponding angles, okay, what does that mean, corresponding? Corresponding angles are the same. What does that mean, corresponding? Do you guys know what this means? What does it mean if two things are corresponding to one another? What that means is that they're in the same relative position. Okay, and I'll explain what that means. So think of it like you have two triangles drawn, and they're basically in the same position. They're not, one of them's not rotated the other way. So for example, here I just drew a triangle with a 90-degree angle. If I draw another triangle, I'm gonna draw it bigger, so it's not the same size, but if the angles are the same, so the angles that are in the same position, the ones that correspond to one another, if they're the same, then these two triangles would be similar. Okay, but only if, you're gonna learn, only if the corresponding sides, so here's another rule, the corresponding sides must be proportional. Proportional. And we'll talk about what this means now. Let's say this side length was 2 centimeters. And I wanted to double the side length. So what's 2 times 2? If I make this side 4 centimeters, okay, right now they're proportional to one another. If this one was 3 centimeters, what should this side length be? According to my ratio here, it should be 6. If it was 7, would these triangles be similar? No, they wouldn't. So in order for it to be similar, the corresponding sides, so the sides that are in the same position as one another, must be proportional. That means they must increase or decrease by the same amount. Okay, so this should be 6. So we're going to look at this example here. Sorry, so we're going to look at this example. We're going to decide, are these two triangles similar to one another? We have to prove whether or not they are or are not similar. Okay, so let's look at the information we're given first. We are given the angle measure. This angle is 60 degrees. And an angle that corresponds to that angle would be which one? Angle E. That's in the same position. Are they equal? Are they the same?
Yes.
Okay, so right now the corresponding angles are equal. Okay, so that's the first rule. The corresponding angles have to be equal. But the sides that correspond to one another have to be proportional. So we need to see the side lengths. And I actually cut this off. What was this side length, AC? What was the measure? This one, 2.4. And this is angle F. I cut that off as well. Okay, so side length, sorry. Side length AC corresponds to which side length? It corresponds with DE. Those are in the same position, right? So we're looking for the ratio here. We want to know side length AC, okay, and we're comparing that to side length DE. How else can you write a ratio? As a fraction, okay? So AC over DE. This is the comparison we're making right now. So let's fill in the length. What is the side length of AC? Thank you. One person's paying attention. And the side length of DE is... Okay, so what's 2.4 divided by 1.2? 2. What that means is that to get from here to here, they did what to the side length? So from here to here, they multiplied by 2, or the other way around, they divided by 2. So the ratio, okay, we're trying to see if the corresponding ratios are proportional. So what that means is that every single ratio in these two triangles must have the same, this is called the scale factor. Do you guys remember this from grade 9? To get from here to here, I'm dividing by 2, or to get from here to here, I'm multiplying by 2. That's the scale factor. You're seeing how the two triangles are related. So we have to see now, we have another two side lengths that are corresponding. I have BC, and which side does this correspond to? EF, right? So BC is 3.7 and EF is 1.5. Let's find the scale factor. What is the ratio there? What's 3.7 divided by 1.5? 47? We'll round it off to approximately 2.47. Are these the same? Is 2 the same as 2.47? So was this decreased or increased by the same value? So what does that mean then? Not similar. These two triangles are not similar because although their corresponding angles were equal, that was a check mark, their corresponding ratios were not proportional, which means that they're not similar. They're different, they are different sizes, but